Hello everyone, welcome to this video lesson. In this video lesson, we are talking from a chapter called ray optics. The topic that we are talking is magnification of the object developed when it has become into an image by a convex and or a concave mirror. So obviously what is happening here is being a mirror, reflection of the light is happening. What is the magnification is the point that we want to identify. So let us consider a simple example to understand what I mean to say. Let us consider a concave mirror. Just for example, I am taking concave mirror. We can consider even a convex mirror also. So the central part of the mirror is called something like pole. The line passing through the pole as well as the optic center or center of curvature is called principal focus. So this is the pole. This is the center of curvature. Somewhere here, focal length will be there because we have proved that principal focus will be there. We have proved that the distance between the pole to focus, which is called as focal length, is equal to half the radius of curvature. That's the distance between P and C. We have done it in the previous lessons. So now, what kind of image is formed? Where it is formed? Is it magnified, erect, virtual, or real? Erect or else inverted? All these things can be decided based on a mirror formula, where mirror formula is 1 by V plus 1 by U equal to 1 by F, and every time we have to apply with a proper sign convention. We will be solving the problems on that in the further video lessons, but let us just consider there is an object here. This is an object. Let us suppose some image is formed somewhere here. The distance between the pole to object, which is measured from the pole, is represented with U. As per the sign convention that we have explained in the previous video lessons, all the distances shall be measured from the object itself. Let us suppose this is the image. This is also measured from the pole. Let us call it like V. And the focal length of this mirror is something like F. We know already there is a formula 1 by V plus 1 by U equal to 1 by F that we have proved in the previous video lesson. And there is some certain sign convention. What is that sign convention? Let us just remind once again to understand this magnification sign. Sign convention is, we have explained this in the previous video lesson also, but anyway, let us do that once again. All distances are measured from the pole. All distances are measured from the pole of the mirror. Next, if distance is measured along the direction of the incident light, along the direction of the incident light, we have to treat that distance as positive, and of course vice versa. If it is measured against the direction of incident light, it shall be treated like negative. Similarly, heights measured on principal axis towards positive y-axis, are positive, and vice versa. That means heights measured along the negative y-axis are treated like negative. Now, let us try to understand what's the meaning of magnification. Magnification is simply ratio of size of the image by size of the object. That means how it is changed. Being they comes, their sizes all depends on the distances, and they forms equilateral triangles also with the distances. So we can also write it as distance of the image by distance of object, where all these distances are measured from the principal focus itself. So if you write little carefully, magnification is minus v by u, that is height of the image by height of the object, where h2 I am treating it like height of the image, h1 is I am treating it like a height of the object. I have applied a negative sign. Let us understand what's the meaning of that. Say for example, let us consider just a scenario. I will consider, say for example, this scenario itself. Say for example, this scenario. There are different possibilities. Say case 1. One point that we need to know is minus sign is there either for v by u, or you can transfer it to the other side, something like minus h2 by h1 equal to v by u. Both are same. It means to tell you that if v and u are in the same direction, h1 and h2 will be in the opposite direction, and vice versa. If v and u are in same sign, that means if both are positive or if both are negative, h2 h1 are opposite. That means h1 will be positive, h2 will be negative, like that, or vice versa. That's the same. Like if h1 and h2 are of same sign, then v and u are of opposite nature. Let us understand what's the meaning of that by taking some different possible cases. Let us consider a case like this. Assume this is a concave mirror. I have kept the object somewhere. When where object is kept and where the image is formed is not a discussion in this post. We will do it in the further post by solving different problems. But let's just assume that I have kept an object like this. Assume that I have got an image here. Let us try talking about sign conventions. All distances are measured from the pole. This is u. This is v. This is the direction of incident light. So you might have seen u is against the direction of incident light, and v is in the direction of incident light itself. So u is negative and v is positive. And you have noticed these two are in opposite directions. That means h1 and h2 will be in the same direction, because u and v are in the opposite directions. So if I write a formula for magnification, this formula minus, let's apply sign convention for each of them. V is positive because it's in the direction of incident light. U is negative because it's against the direction of the incident light. Both H2 and H1 are about the positive y-axis, so both of them are treated like positive, right? So what's happening? Minus and minus gets cancels. Magnification is V by U, or that's nothing but equal to H2 by H1, where magnification M is treated like positive. Let us write one more case to understand what happens in the other possibility. Say for example, case 2. Let me try identifying a diagram. Same concave mirror. I have kept the object somewhere. And the image is formed, say for example, on the same side. Just for example, image. It's very clear, being both of them are in the same direction, u as well as v. H1 and H2 cannot be in the same direction. So H2 won't be able to be formed there like it was drawn here. Rather, H2 will be formed in the reverse way because u and v are in the same direction and H1 and H2 has to be in the opposite direction. Let's try writing a magnification formula again. M equal to minus V. V is negative because this is the direction of incident light. This is how I have measured V against incident light. U is also negative because that is also measured against the direction of incident light. H2 is reverse, negative y-axis. H1 is positive. So if you write a magnification, it will be minus and minus gets cancelled. Minus V by U or minus H2 by H1, which is negative. So in a nutshell, I can say if the image is virtual, magnification is positive. If the image is real, magnification can be positive or negative depending on the nature of the images, right? I'll stop here because this is a detailed further lengthy discussions can also be made that when I will get a real image and when I will get a virtual image. That we will handle when we come back to the next video lesson. Thank you for watching. Keep coming back for more and more video lessons. Thank you.